What's up, everyone? My name is Biku, and I am back with my latest project. Kinda looks like C3PO threw up onto a breadboard. This side looks a lot cleaner, at least. Now, what is this? Some of you might be looking at some of these things and might have some guesses, but I, as many of you do, was watching Maker's Muse build robots constantly and decided I wanted to have on some of the fun. But unfortunately, because of where I live, a lot of these things are either a lot more expensive, or B, not as easy to get a hold of, like radio controllers, remote controls, the little mini motors that you use, especially for the little mini battle bots that he's building. Spoiler: this didn't end up being that mini, but hey, it was part of the fun. So I decided, as many of you may do when you start a new hobby, you think, hey, what do I have lying around? What did I have? Stepper motors. Now, if any of you know anything about stepper motors, you may be thinking, why would you use a stepper motor for anything even resembling a combat robot or an RC robot? That seems stupid. And yes, it is, I agree. But at the same time, I have a bunch of these lying around from either building printers or stripping down printers, so why go buy new motors when I have motors and controllers? Or not controllers, drivers. Now, that's motors done. But you know what else you need for a RC car? Well, you kind of need a controller. Now, I don't have a radio controller and a radio control that you would use for like an RC car or something like that, but what I do have is a couple of Raspberry Pis. Now, again, if you know anything about these types of things, you would be thinking, why would you use a Raspberry Pi for this? I mean, obviously you can, but why? Well, again, I had it lying around, and I kind of just wanted to play around without investing too much into something that I didn't really know if I was going to take very far. But then, okay, you've got the controller for the little robot. What next? Well, I have a couple Switch controllers lying around. Now, this is a robot. At least not in its current state, it isn't, but it will be. Unfortunately, I don't have much video of me actually building this, because it's not the type of thing I really even knew if it was going to work, and I didn't want to spend time setting up cameras and recording if it, was just going to not work very well. But it ended up working pretty well. No, these are not AA batteries, AA battery holders, or what would that be, A battery holders? These are quite big. I'll get to those just now because that's kind of part of the sketchiness of this. But I started out, as again, many of you would, with the humble breadboard. And again, as I'm sure many of you have come across over the years, the humble electronic box of crap, or at least it ends up turning into a box of crap. And I'll see if I can put in a video of my first little tests of powering up the motors with the breadboard, but it looked kind of terrifying. I'd worked with breadboards in the past, but nothing really this complex, so this was definitely a first. So, how did I get all this to work? Well, this is a Raspberry Pi, and this is kind of the interesting things that I found along the way. A Raspberry Pi has GPIO pins. Obviously, this one didn't come with the pins on, so you can see my beautiful soldering there to get them on. It works, don't judge. But how do you actually control them? Now, I'm not going to go too far into the programming or the code in this, because this is more just showcasing the little thing that I built, as well as giving you some insights I learned along the way. But controlling things off of the Raspberry Pi GPIO is not actually as beginner friendly as it would make it out to be. Especially with how I wanted to do this, where I don't want to have to plug this in and have a GUI. I wanted to run this headless, where it just connects to Wi-Fi and you SSH in and control it, which was interesting, but ended up working quite well. So, okay, this is the controller. If you think about it, you connect things to these pins to control things. Fair enough. That is what this board is for. This is for actually translating and powering everything so that the pins go where they need to go. Now, this is not professional or neat at all. This is very, very messy, but hey, it does work, surprisingly. And this is the first. I wish I could get VIA board and not just the strip board. You can see this is a blank one. It has these strips of PCB traces. And this is great. This is effectively a breadboard as a PCB. But the problem is, if you need to connect things along this way, it's fine. But what if you needed to connect multiple things here and you don't want them bridging in between? If you connect something to this trace here and a trace here and a trace here, it's going to be connected. So you need to actually break these connections. And all over, you can see there are these nice little marks there, all between these pins here, where you literally just go along with a knife and you just break the connection. Now, one thing that is pretty crucial for any project like this is a multimeter. Now, I would not recommend trying something like this without a multimeter, and I'll get into more of why I think that in a little bit, but I'm sure many of you have used a multimeter before, but for the very simple purpose of just checking continuity between pins, a multimeter is essential to make sure that you haven't gotten any bridge connections and that things are going to work reliably. Another thing that's very important when you're doing something like this is some form of schematic. Now, I have one. I'm not going to show it to you because it's horrible. It looks like a 3-year-old drew it. But I have a schematic that more or less shows where all these wires need to join and where everything needs to go. And that was very, very important when laying this out, because when you're doing something like this and you're running a wire, you really don't want to run it to the wrong place. And having something that you can just double check to make sure is very, very important. Great, so we have the motors, we have the controller, we have the distribution board. Last thing we need is drivers. Now, these are ripped off of a 3D printer. Anyone that's worked on any 3D printer, maybe not the recent ones, but any oldish 3D printer will know these as the good old A4988 Pololu driver. I do have a bunch of these DRV8825 drivers, but every time I try to use these thinking, oh, these will give higher current, be more stable, higher microstepping, not that I'm using microstepping, these just never worked out that great. So Pololu A4988 drivers it is. Now, that's great. We've got motor, controller, board, and drivers. How do we power this? Now, if you're wondering, like I said before, these are not standard AA battery holders. They hold these. Yes, all the vapors in the crowd will know what these are. These are 18650 lithium-ion batteries. If you could read that there. Now, these are actually quite beefy ones. These are 3,000 milliamp hours each. And I'm running these in series, so I'm getting a nominal voltage of about 7.2 volts. They go in here. If you want to use this for any reliable robotic system at all, do not use one of these. This was literally the cheapest thing I could find to house these things without me having to get a battery tab welder that I didn't want to do and mess with. So this is as simple as it gets. It is literally some pieces of metal that connect these things and some wires. No, these aren't the original wires that came with it. This thing came with wires so thin that I actually worried it would melt the solder when it was actually pulling a decent amount of wattage through here. So I took it apart and replaced the wires with some chunkier wires that are better rated. Now, if any of you know anything about battery safety, maybe don't watch this, but this is pretty much as rudimentary as it gets. I am putting these batteries in here and turning the switch. I have an external charger for the batteries. They are really cheap, but I mean, hey, they've been charging them fine so far. And that is pretty much it. I have no BMS, I have no charging circuitry in here at all. That means the other reason why, if you're going to try anything like this, a multimeter is essential. Why? These batteries have, and this is now going into some lithium ion chemistry, I don't know if you can see the multimeter there. These batteries have a charge to them. So let's see if we can get this one's charge. You see there it's about 4 volts. So on the data sheet for these have a operating voltage of roughly 2.5 volts to 4.2 volts. Lithium ion batteries are very, very spicy. Not as spicy as lithium polymer, but still very spicy batteries. If you discharge these below their minimum voltage, 1, they might just never work again. 2, you can actually start a thermal runaway event. The same thing as if you overcharge them. Now, in a proper system, you would have a battery management system, or BMS, as well as a charging circuit in here to charge these things uniformly and make sure that they're not going out of their rated voltages. Like I said, I don't have any of that. I am checking these things with a multimeter, making sure they're in a safe voltage range, and then checking them often when it's running to make sure they're not going out of that range. Great, but I hope you noticed, that gives me a voltage of 7.2 volts. These motors and the drivers need anywhere from 12 to 24 volts to run well, 24 volts ideally, and this needs 5 volts to run. How am I going to get that 7.2 volts to 12 volts and 5 volts? Well, that's where this and this come in. This is a buck boost converter. This takes the 7.4 volts and boosts it to 24 volts for the motors. This is just a buck converter that converts the 7.4 volts to 5 volts for the Raspberry Pi. And then the wires are just connecting everything together. I'll get to this button later. That's some of the fun when it comes to using something like this as a control system. So great, I have all the parts for a robot. How do we actually use it? That is when this chunk comes along. Now, again, I'm not going to put these files online. No one should build something like this. And even if you wanted to, it's very simple to build something like this. It's very straightforward to model and to print out. But what this is effectively is just 2 motors in a big chunk of 3D printed plastic with some wheels. You can see I've got some electrical tape on the wheels just to give them a little bit more grip, because the bare plastic is not very grippy at all. And then the motors come out the top. Oh, and a couple bearings, just because I didn't want to have to deal with adding some sort of gear system to get 4 wheels. So the bearings are just so that it can glide smoothly when it reverses or goes forward. So, shall we put this whole thing together? One thing I wanted to say that I learned along the way. In my magical box of tech crap, there was one of these. Now this is designed, I'll get to that just now. This is designed to put onto a breadboard so that you can have power going down the power rails of your breadboard. You plug a power supply in here. Now on here, this can supply 5 volts and 3.3 volts. I hope you can see that. And what actually converts your inputs to those is these 2 little tiny voltage regulators. Now, I'll put the model number for these regulators up on screen, but one is 3.3 and one is 5 volts. Now I thought, oh, great, I'll just take this out, and then I can just use this to supply my 5 volts for my Pi. Now, this is where just using what you have on hand can bite you in the butt. These technically do output 5.5 volts, but the problem is, depending on what voltages you're converting from, these things can get really hot really quickly. And converting from how I did it initially was going off of the 12 volts when I was still running the motors in 12 volts to 5 volts. That means that this thing has to shed a lot of heat. And this thing, I burned out, I think, 3 of these trying to get it to work. Eventually I just sprung for an extra, I don't know, in South African rands, I think it was 20 rand for this buck converter, and now no issues. Plus I can run the motors at a higher voltage. Plus I don't have to worry, I had a cap extra capacitor on here because that needed extra components. Yeah. Sometimes it is better to just shell out the little bit extra to get something that runs more reliably. Not to mention, if one of these popped, and how I had some of them pop was that they blew open, meaning that the Pi was then going to be getting 12 volts directly to it instead of 5, which is bad. Technically it has protection against that, but you don't want to risk it. Not to mention it was running extremely hot. Okay, let's get this thing put together. Great, all together. Now, every time I turn this on, I throw the dice because, hey, this is running a computer. You never know what's going to happen. Okay, so it's on. Unfortunately, again, because this is a computer and this is running Raspbian, this does take a minute to start up, but you can see the little blinky lights on the Pi trucking along, and currently when it starts up the motors are locked. But there's a couple cool things that I've built into this, and I'm going to get into a little bit of the software once this is on and running, and then I'll kind of wrap this up and give my thoughts about this whole experience. Okay, so the motors are now free spinning. So that means that my script that is running all this is live. So technically, if I now power up this remote control, it should connect. And it's connected there. Now, the way that I have set this up, currently when it starts up, the motors are locked, the motors are off. If I push the home button on the controller, now the motors are no longer free spinning, and technically this thing should be controllable. Okay, so that's all awesome. I can increase the speed. I really don't want this thing to jump off the table. You can see it actually gets up to a decent, I don't know if you'll be able to hear me over that, it actually gets up to a decent speed. So that is pretty much it. This is very simple tank steering, this is very simple tank steering. Move it up, it goes forward, back goes back. Left, right, turns it left, right, and also spins. So, this is awesome. This was super fun. I've the joy of putting all this together the first time reminded me of the first time I had built my first fully functioning 3D printer, which is awesome. And I mean, obviously I learned a lot doing this, but there's a couple key takeaways that I kind of wanted to bring out and let everyone know about this. One, if you want to try something, it's worth looking at what you have lying around. I fully intend on at some point using these drone motors that I salvaged from a scrap DJI Phantom for doing something with this at some point. But I don't have the ESCs on hand, and they're honestly not that cheap in my country to just outright buy an ESC. So for now, I'm going to leave it. But what I did have, because again, I've been playing with 3D printers on and off for the past 10 years at this point, and what I had is a lot of stepper motors and motor drivers and an Arduino lying around. The rest of the stuff to put this together, I mean, the batteries were probably the single most expensive thing, but I mean, in dollars, this probably cost me around $20 of additional components in total. I'm not saying that where I'm from in rands, $20 Doesn't mean a lot more than it does to you guys in the States, but still, it's not that much. What did I learn? I learned a couple things. One, sometimes it is not worth using the thing that you have on hand, especially if you don't want to break things. And at the end of the day, spending an extra 20 Rand on another converter to get the right voltage for the Pi made this thing more stable overall. Because before I had to run little fans to cool that little converter, and I didn't trust it. I didn't want to run it for long periods. What did I learn? 2. Lithium batteries, and I knew this beforehand, but this kind of re-established my existing fears. These things can be scary. Nothing happened while I was doing this, and I worked with a lot of lithium batteries in my previous job. Lithium batteries are scary. If you don't know what you're doing, do not play with them like this. Buy an ESC, buy a LiPo pack with the managed ports, and buy a proper charger. Do that. What did I learn? 3. Raspberry Pis are awesome. I mean, I knew this already. I've been playing around with them for a while already. But really, the fact that I am using this computer that can run a full desktop operating system, I'm running it fully headless as a radio controller pairing to a Nintendo Switch controller, controlling my little robot. That's awesome. I had all that lying around. What did I learn? 4? Vibe coding is interesting. Now, vibe coding is... I'm going to say this with the biggest asterisk ever. Vibe coding is fun. It's awesome. But there's some very, very big caveats. This thing, the script that is running this, is never going to be connected to the internet. It's never going to be... The Pi itself can connect to the internet, sure, but the actual script that runs this is never going to do anything online connected. I'm never going to, open ports and let myself control this thing remotely. Why? As much as having ChatGPT or whatever AI is your flavor spew out code that can make something work, and legitimately, you saw it, made it work. I didn't code anything by hand. I made some tweaks here and there, but I didn't do anything by hand, is awesome and enables people to do things that they, wouldn't otherwise want to do. If I didn't have ChatGPT available as an option, this would have taken me probably an extra month of learning how to do all these things. Now, that takes me to it. What did I not learn? I didn't learn how to code. I didn't learn how to code a Python script. I learned how to run them. I learned how to set them going automatic, but I didn't actually learn how to code a Python script. Now, I have some programming background, not programming itself, mostly PowerShell scripting and some JavaScript and some Delphi when I was in school, but I'm not a programmer. At work, I deal with a lot of programmers and code, and I do kind of know how to read through code, but I'm not myself a programmer. I couldn't actually program the script that runs this, and I'm not going to post it online. It's very specific to this. I mean, you shouldn't be using stepper motors for something like this. You really shouldn't be, but I am, because that's what I had on hand. That takes me to the third thing. Stepper motors are kind of shit, but they're also amazing. Why do I say that? If I run this, there, you see that. One of the motors didn't run. Why is that? Stepper motors are, in essence, they are the same as this. They are brushless motors. The difference is, this is what's called a three-phase BLDC, I believe. But long story short, this needs an electronic speed controller, and you can see in there's motor windings and there's magnets, and the three-phase coils of this, the alternating coils, make this spin. A stepper motor is slightly different in that this has locked in steps of motors. As much as this is a brushless motor, this has two pairs of coils inside that, by alternating between the coils, jumps between the different steps or magnets inside the motor, which makes it amazing for high precision, like for example 3D printers. Almost every single 3D printer on the market today uses stepper motors, and not a lot of them, I think there's a couple, but not a lot of them use closed loop control, because if you run stepper motors within their limits, they are amazing. They can run for days at a time with perfect accuracy. But it's when you start running them out of their limits, either too fast or with too high torque, that things start to lose steps. But for something like this, where I just wanted to play around, they're pretty cool. They don't go that fast before they start losing, before they start jamming and stop working as they should. But I mean, the biggest issue on this, I bumped up the voltage on the motors to 24 volts. At 12 volts, it really wasn't great. At 24 volts, it's not bad. It can get decently fast. So I say this again. If you want to vibe code something, by all means give it a shot. For a lot of people, it can be their first introduction and get them interested in doing this. But, never. Unless you really are confident that you've gone over everything and are not going to be doing things, never vibe code anything that's going to be broadly accessible on the internet, because I have seen and I have heard and I have witnessed the things that AI can do that you will not understand why it is a vulnerability. Yeah. Be careful, but have fun. That's why something like this, it's a perfect little project for it. Plus, it lets you iterate really quickly without needing to understand things. Like, for example, when I first got the Tang steering working, that with just direct one-to-one motor control was horrible, because you turn slightly and all of a sudden it spins. Communicating that in natural language with an LLM, telling it, hey, this is happening, what's the solution, and it being able to tell you can do differential steering and rate and change the rate of speed depending on how far you're turning, that's cool. It probably would have taken me months to figure that out. I probably would have been able to in the end, but this whole build took me about 2 weeks. So yeah, I think I'm going to leave it off there. Leave a like if you enjoyed watching. Try something like this yourself. You'll be amazed what you can do with shit that you have lying around. And yeah, thanks for watching. Bye.